This video accompanies Lift Operation Part 1 and covers tips for smooth lift operation as well as troubleshooting guidance. For an in-depth explanation of DBS lifts, refer to Part 1. Bridge deflection plays a crucial role in understanding lift operation and troubleshooting effectively. The bridge deflects under a dead weight, delta 1. This includes the weight of the drive unit and the rake mechanism suspended from the drive unit. When the lift activates, the bridge experiences additional deflection, delta 2, due to the forces needed to pull the rake from the mud. This extra deflection serves as a key indicator of how efficiently the lifting capacity is being delivered to the rake. The total deflection on the bridge is delta 1 plus delta 2. It's important to establish a baseline bridge deflection during normal lift operation before issues arise. To identify a diminished lift capacity, compare the total bridge deflection during lifting to the baseline. A total deflection less than the baseline indicates reduced lift capacity delivered to the rake. This could suggest an issue with the actuator or that a significant portion of the lift capacity is being consumed by friction forces. The forces acting on the lift can be broken into 3 components. With only one force component contributing to bridge deflection, the other 2 are consumed by internal friction forces within the drive unit. In extreme cases, these internal friction forces can consume the entire lift capacity. The forces are: Force 1, the force from the weight of everything hanging from the drive unit. Force 2, the forces on the key shoes, which are proportional to torque. And Force 3, the forces on the hub caused by an overturning moment. Force 1 contributes to bridge deflection, while Forces 2 and 3 do not. The clarifier manufacturer specifies a lift capacity limit to protect the bridge and rake from damage. DBS utilizes a relief valve on the screw jack to enforce this maximum lift capacity. This protects the bridge, rake, and drive unit from damage. The screw jack is actuated by a hydraulic motor, which delivers a torque proportional to pressure. The relief valve limits the available pressure to the hydraulic motor, thus limiting the overall lift capacity. If the lift cannot raise the rake, try the following. Minimize the torque on the key shoes by stopping rotation while lifting. This alleviates the friction caused by the forces on the key shoes. Additionally, make sure the surfaces of the keys are well lubricated. This minimizes the coefficient of friction and decreases the amount of force needed to lift. Minimize the overturning moment by ensuring an even distribution of mud over the rake. This helps reduce friction between the rake shaft and hub. In practice, this is hard to identify, but proper lubrication can decrease the effect of the overturning moment. Overall, adequate lubrication throughout the unit is key to successful lift operation. Rough contact surfaces and improper lubrication increase friction and hinder performance. Identify issues with the lift actuator by utilizing the emergency lift capabilities on your drive to bypass it. To do this, disengage the actuator, then use the manual crank. If manual lift operation works, the source of the problem is in the lift actuator. Check the max pressure while lifting. First, inspect the pressure gauge. If the max pressure is less than specified, check the relief valve. If the relief valve is engaging at the wrong PSI, use the test valve to recalibrate it. If there appears to be no mechanical issues with the unit, the rake may be stuck in the mud. Use the directional valve to maneuver the rake out of the mud with up and down motions. You can also try moving the rakes back and forth while maintaining upward lifting force. Be careful not to overheat the actuator. If you're still experiencing trouble lifting, DBS's team of engineers is available by phone or email to assist you. Service is available in English, Spanish, and Chinese. Visit dbsmfg.com for more information.